We want to solve for x in this logarithmic equation. We're going to do that by making the conversion from logarithmic form to exponential form, and we know that logarithms are exponents. So the logarithm is the exponent. So the exponent here is 3. Exponents go on bases, right? So it's going to be x to the 3 is equal to 5. But now this is x cubed. I don't want x cubed. Why don't we take the cube root of both sides, and that will bring us right to x equals the cube root of 5. Now let me just run a quick check on something here. This x is in the base. I have to be sure, remember now, that when we write the base is greater than 0 but not equal to 1. And when I see this, all right, that is a number greater than 0 and is not 1. So we're okay. See what we can do about getting x out of this number 37 here. We're given that the logarithm base 5 of 25 is x. Let's get it out of log form into exponential form. We can do that if we know that logarithms are exponents. So the exponent here is x. That's going to go on that base, which is 5. So if we just write it, 5 to the x is 25. Now we know that one, right? X is 2. 39, we've got x, the variable, in the base. So we'll have to be a little bit careful, make sure it's a positive number, not equal to 1. So let's just convert it from log form to exponential form. Logarithms are exponents. So the exponent is 2. That goes on x, so we'll write it. So we'll get x to the 2. X squared is 36. Now, I'm going to write here that x is going to be 6. And I know this because if I actually solve that equation, now, the last time we ran something like this, we solved it by factoring. If I do this, if I just square root each side, over here I get, right, remember the absolute value of x equals, this one I know is 6. And then when I remove the absolute value, now I get plus or minus 6. So I'm really looking at negative 6, positive 6. But I know because it's the base, it cannot be that negative number. So we can toss this one out and just claim now that x is 6. I'll try. Okay, x is 6. Let's solve for x in 41. Log base 16 of 8 is x, so logarithms are exponents. That exponent goes on that base, so let's write it. 16 to some power is equal to 8. Now let's think about this. We've come across this before where what does that x have to be? If it's a 1, then I would get 16. If it's bigger than 1, this number would be bigger than 16. But this number is smaller than 16, so that x has to be smaller than 1. So it's going to be some kind of a fraction. So I'm thinking this maybe. X is equal to some kind of a fraction. Now in these types of problems, fractional exponents, the denominator, the bottom number here tells me the root. Now what roots do I know of 16? Well, I know a square root. A square root would be 4. I know a fourth root, that would be 2. So there's 2 possibilities here. So I'll write them both, and we'll just see which one kind of helps us out here. Could be a square root, could be a fourth root. Now, if it's a square root, then I'm thinking this. 16 to the something over 2 equals, now what would this be? This would be 4 raised to, the numerator, remember, tells you the power to raise it to. So the square root of 16 is 4, so this would be 4 raised to some power, giving me 8, right? There's that 8 right there. Well, 4 to some power is 8. I don't know what that is, so I don't think this is going to help us too much. Let's try the next one. So if I try the denominator being 4, right, what's the fourth root, right? I'm looking at this then. It'd be 16 to the something over 4. Now, I know that the fourth root of 16 is 2. So this is going to be 2 to, remember the numerator tells you the power that you want to raise to. So 2 to the something is 8. And I know that one, right? That's got to be a 3. So that tells me what to put in here. I'm going to put that 3 right over here. So I'm saying that 16 to the 3/4 is 8. Now let's just check it real quickly. The fourth root of 16 is 2. 2 to the third, right? The bottom number is the root. 4 through 16 is 2. The top number is the power, 8. So 4 through 16 is 2. 2 to the third is 8. So our value for x is equal to 3/4. That one required some thought, didn't it? Now it looks like this number 43 is similar to that 41. In this sense here, I've got 9 raised to some power giving us a third, right? Logarithm is the exponent. So let's write what we have. 9 to the x equals 1/3. Now this is a fraction over here. That means that this has to be negative. Just run through it quickly. If this was a 1, we would get a 9. If it was bigger than 1, we'd get some number bigger than 9. If this was some positive fraction, we would get like the square root of 9, which is 3 or something. But now it's a fraction. So this is going to be a negative fraction. This number is smaller than 9, and it's a fraction. So this has to be a negative number, and it's a negative fraction. So what could we possibly put here? So 9 to the what? Well, what kind of fractions do you know where if you take the denominator, the denominator is the root, right? The root. What roots of 9 do you know? Well, only one, the square root, right? So this is going to have to be a 2. So far we're dealing with this. This would be the square root of 9. Now that's going to give us a 3. Now I got the 3 right here. Right, there's the 3. But I've got 1 over 3. This is 1 over 3. So the 3 is just to the first power. So I think it's just to the 1/2, right? 9 to the 1/2 is 3. But I want 1 over 3. So why don't I make this 9 to the negative 1/2? That would be 1 over 9 to the positive 1/2, which is 1 over 3. So I think we've got it here. X is equal to, what did we get? Negative 1/2. Well, that was a lot of talking, a lot of hand waving. I hope that made sense to you. I'm going to run over it myself, make sure it makes sense to me.